So now they've just jammed everything else together, and then we get a table at the end to complete. So going decimals to percents, you just multiply by 100 and put a percent sign after it. So the opposite of what we were just doing. Fractions to percents, convert it to a decimal, which means do the long division or crunch it on the calculator, and then multiply by 100. That's the way most people do it. I mean, there are a few fractions that you kind of gut remember the percent on, so that's fine. Or to me, it's you take whatever the fraction is, and yeah, that's it. And then converting fractions to decimals, do the division. So that's why they put them in that order, because the last one is a combination of the first two here. So yay for the calculators. Why is the back of my brain saying we're missing something? Oh, decimals back to fractions we did before, because you put it over whatever the respective power of 10 is. All right. So convert a fraction, complete the table. So if I have a fraction, figure out the decimal, figure out the percent. So 18 over 25. I could crunch that on the calculator, but I do happen to know 25 works nicely with 100. If I multiply by 4, I would get 100, which then I can convert to my nice decimal. So the 18 times 4 is 72. So this is the same as 72 over 100. That's an equivalent fraction. And then the decimal would be 0.72. Then multiply by 100 to get 72%. The percent sign is your units here. So you have to write percent when you mean percent and not write it when you don't want it there. Now 4.9. So that is 4 9/10, which, you know, technically. But 4 wholes split into 10 pieces is 40 plus the 9. 49/10. And then multiply by 100. So this becomes the whopping 490%. Now the 35, going from a percent to a decimal, boink, boink, 0.35. And taking this to a fraction, that is, I'll write it over here, 35 over 100, top and bottom divisible by 5. So we get 20 on the bottom and 7 on top now. All right, so 0.48, kind of backwards of what we were doing on C. So to go back to the percent, I multiply by 100 and have 48% now. Now I'm just going to figure out what 48 over 100 is. So let's see. 6 times 8, so there's no 5s in there, so I just need to divide by the 4 that it has in common with the 10. So 12 and 25. And, you know, 12/25 is a little bit less than half, because half of 25 would be 12.5, and we look, our decimal is a little bit less than 0.5. Our percent is a little bit less than 50%, so if you're ever not sure, like, think of what you know that number to mean, and is what you wrote down for the rest jiving with that meaning. Now 7/11. This is the point where we go, why? Why would you do this? Seven divided by 11. I don't like repeating decimals. So this is 0.63636363. So I'm going to write it with that bar over the top. Otherwise, they would give you in the directions how many places to round to if it goes on and on and on. So when we multiply by the 100, we are going to get 63.63 repeating %. Now, the interesting thing is, like, we've got the extra 63 holes in front now for the percent, but the 0.63 repeating is the decimal we just had, which is 7/11. So I could also write that as 63 7/11%, strangely. All right, last one, 4.5, just like 35. The decimal made that smaller, so this is not going to become 450. It's going to go the other way, and we're going to get 0.045, which that is 10/100 thousandths, 45 1/1000ths. All right, well, divisible by 5. In fact, that is 9 5s. And the bottom, 1,000 split 5 ways, or $10, which is 1,000 pennies. $10 split 5 ways is $2 each, or 200 pennies. So it is 200. And that's our last fraction. 9/200. All right. So here, it's not about doing these quickly. It's more about having a frame of reference and understanding how the three relate and how they should look. So if I see a percentage that's between like 1 and 100, then I expect to see a decimal that doesn't have a number in front. So percents over 100, when they convert to a decimal, that means they have at least one whole. So there's still a number in front of the decimal when I convert to the decimal. And likewise, that then gives me mixed fractions or improper fractions. So it's not so much about being able, again, you don't need to do this quickly. You don't need to do any of the calculations quickly. You need to do them consistently. So if that is, you're comfortable doing it on your calculator, do that and be good at that and happy with that and confident in that. You do not need to do these by hand. Like even I pulled out the calculator for 7/11 because it was like, no, I don't want to do that. All right. So there is that one.